Okay, so here we introduced there are two numbers. One is called atomic number, okay, of the mass, atomic number of the atom. Another is about the mass number, the mass number of the atom. So here is another question. So for this one, what's that? So find the number of protons, neutrons, electrons, and the atomic number and the mass number. Anyone want to try?
Proton number is 9, neutron number is 10, electron number is 9, atomic number is 19.
Okay.
Oh, mass number is 19. Atomic number 5.
9.
Atomic number?
9.
9, yes. Mass number?
19.
19, yes. So number of protons is 10, right? Neutron, no, proton is 9. Proton is 9. And the neutron is 10, okay? And the electron is 9. And the atomic number is 9, and the mass number is 90. Okay, yeah, here's the answer. Like this, okay?
Yes.
This one, what difference from above? Here is 1 plus. 1 plus, what does this mean?
It gives out 1.
Yes, it's loose, right? Loose 1 electron, right? Give out 1 electron. Okay, so in this case, what number of proton? 11. And what number of neutron?
Yes.
12. What number of electrons?
10.
Why?
Because it gives out 1.
Yes, good. Atomic number?
11.
11.
Every time I look at it,
Mass number?
20.
Yes, 11. This atomic number and this is mass number. Yeah. So here is the answer. So here we can see the number of electrons should be 10 now because it's loose 1 electron. Okay. So here is about isotopicus. So what is isotopicus? So yeah. Basically, for each atom, for each element, it has isotopicus. So this means atoms of the same element can have different number of neutrons. So the element can, one atom can have, there are protons, and the number of protons and the electrons are certain, okay? But the number of neutrons can change. So all these kinds of, but this atom, they still have the same number of protons. So they are the same atom. So all these atoms are called isotopicus. So for example, for carbon, okay, so basically carbon, a very common atom is like this, right? 6, 12. But also this also carbon, because the neutron is 6, and but the proton is 6. But the neutron, it has 1 more neutron. This has 2 more neutron. So all them are carbon, but all these carbon atoms are called isotopicus. Okay, so because one element can have different atoms, like isotopicus. So how to calculate the mass, the atomic mass? So basically using average atomic mass. So because the abundance of the isotopicus of different elements in neutron are constant. So we can define the average atomic mass. So average atomic mass means the abundance of the percent, okay? Time mass. This is A, B, and okay, I should be B, sorry. So like this, okay? If it only includes two isotopes, so just the mass A, percent A, mass B, percent B. So this, using this way, we can get the average atomic mass. Like, for example, chloride. So it has only two isotopes. So one is chloride 35. This is more than 70%. It's 75.56%. In the nature, okay, they are 70. This number, this percent of Cl35. There are still some 24.47 chloride, 37. Okay, so what the average? How to calculate the average atomic mass of chloride? Okay. Mass and the abundance, mass abundance, right?
Yes.
So 35. This is the mass, atomic mass, right? And this is the abundance, right?
Yes.
Okay. So we can use this way. Oh, yeah, just no. It's like 35 times this one, right?
Yes.
And 67 and this one, and finally we can get the. Okay, question. Oh, this is the same, right? Yeah, this is the question. Yes. So should be like this. So using this abundance times this mass, okay, and also this times this mass, we can get this mass. So this is called average atomic mass. So second question. You know, average relative atomic mass of carbon is this 12.0107. Accounting for carbon 12, this is abundance, okay, and carbon 13. So why? So just we use it from this number to confirm the average relative atomic mass of carbon is this number. Cool. So basically we can say this sign in the book, right? So this is average atomic mass. So basically just use this abundance atomic mass, this atomic mass we get this number. So this is average atomic mass. Okay, this one has more isotopes. Okay, so we can say, for example, this is the mass number. Mass number, for example, 196, okay, 198, 199. And this guy, the percent of this guy is 202 is 29.8. Yeah, let me see, 29.8. So this is atomic mass. This is abundance. So how to calculate the average atomic mass? Should be similar, right? How to do? Yes, mass times the percentage, like this. Okay. There are so total 7 isotopes. We just put all the 7 isotopes together. Okay, we can use this way to calculate the average atomic mass. And finally, we can get this number. is this number. Okay? So atoms, basically atoms are still very, very light and very, very small. Okay? So if you just using light centimeter or meter or grain, so the number will be very, very small, right? So yeah, very tiny. So we can using other way to define the to describe the size and the mass of atoms. Okay, so here we give one unit. It's called AMU, just atomic mass unit. So unit, basically we're using like atomic mass unit, AMU. So how to define AMU? So we know the mass of one carbon atom is this number. Okay, it's very small, right? Green. The unit is green. It's green. So one AMU means 1/12 the mass of carbon atom. So this number divided by 12, we get this number. Okay, this green, right? So this number, this green is called 1 AMU. So from here we can see how many AMU of carbon? 12. Yes, 12. How many AMU? Because 1/12 mass of carbon is 1 AMU. So of course the carbon has 12 AMU, right? So when we use AMU as a unit of the mass, we can say the mass of carbon is 12 AMU. Okay, 12 AMU. Okay, using this way, we will calculate the number of AMU for other particles. For example, proton, green, the mass, if using green, it's like this green, okay? This green. And then, so this number divided by this number will get 1.0073. Now, what's the unit? The unit is AMU. Okay, so we can say the proton is almost 1 AMU. Almost 1 AMU. Okay. And the neutron, okay, the neutron, for one neutron, the mass is this number of green. And this green divided by this number of green. So we can get 1.0087 AMU. Proton. So we can say proton and neutron, the mass of proton and neutron, they're almost similar. Okay, similar. But of course, when the proton is +1 charge and the neutron is neutral. What's the mass of electron? So the mass of electron is this green. So here is 10 to power of minus 28. So if change it to MU, it's this number. Okay, so this one is much smaller than this two, right? So basically, when we calculate the mass of atom, we don't put this inside. We don't consider the mass of electron because it's too small. It's too small. Okay. So this is about if we use AMU as unit of mass, we can get numbers of different particles. Okay, this is about the mass. Length. Length basically we name angstrom. 10 to 10 to the power of minus 10, right? Meter. So this Lambo meter is called 1 angstrom. 1 angstrom. So typically, the typical atomic emissions are like 1 to 5 this meter. So we can say it's about 1 to 5 angstrom. Okay, so we use this way to describe the length. So it becomes more easy. Okay, so any questions for this? Yeah, the mass and the length. Okay, so we can use mu and angstrom to describe the mass and the length of the atoms. Okay. So now we introduce what is relative atomic mass. So mass can be used like green, right, or AMU. And here we also can use relative atomic mass. So relative scales have been developed to compare the relative mass of atom. The atomic mass of an atom is relative mass on this scale. You know, and we also see we just set the mass of carbon is 2. Okay, it's 2. So this green is just we set the mass of the carbon is 2. Okay, so for other atoms we can use this number to describe their mass. So this mass is called relative atomic mass. So for example, sodium, okay, the mass is green, and this number divided by the mass of carbon. This number we can get this. Okay. So this one, is the relative atomic mass. And the relative atomic mass have no units. Because the green they will offset, right? So they have no unit. So this is called relative atomic mass. So the relative molecular mass is the sum of relative atomic mass. So this is for one molecule. It may include more than one atom. So the sum of relative atomic mass is called the relative molecular mass. For example, water. Okay, so it includes 2 hydrogen and 1 oxygen. So its relative molecular mass is we can just 2 hydrogen, 1 oxygen, add them together to get the relative molecular mass. And also, no unit. Because relative atomic mass, no unit. So the relative molecular mass, also no unit. Okay. Here we introduce Avogadro's number. So how to learn this number. So this number means the number of atoms in exactly 12 grams of carbon. So in 12 grams of carbon, we can get the number of atoms from some experiments, okay? And the number of atoms is this number. So in 12 grams of carbon, there are this number of atoms. So this number is called Avogadro's number. Okay? And also, this number we also call 1 mole. 1 mole. Okay? So 1 mole is like a unit containing this number of atom. This number of atom. Okay. So this means 1 mole. If 1 mole atom, it may be atoms or molecules. Molecules. So 1 mole of any atom or molecule contains the same number of atoms. Okay. So the mass in grams of 1 mole of atoms or molecules is equal to relative atomic or molecular mass. So 1 mole of sodium weighs this gram. So 1 mole of water, this is a compound, right? This is a molecule. So it weighs this. So the mass of 1 mole of atoms is called molar mass. Molar mass. And it has units. The unit is gram mole. So we should know. So atom, what is for 1 atom or 1 molecule? It has molecular mass. Molecular mass. And the molecular mass has the unit. It's gram per mole. Gram per mole. Yeah?
So is it okay if we round up 6.0 to 2137? Or just to 6? Instead of saying 6.0222137 times 10 to the power 23.
When you do calculations, you mean?
Yeah.
Okay, just to like basically 3.02, it's okay. Yeah, you don't need using all other numbers. Yeah, that's 6.02. Okay. One question. Okay, now I have a question. How many moles of iron are there in 0.2323 of iron? And how many atoms in 8.232 grams of iron? Yeah, I need someone to come here to show the answer.
Our second monitor.
Wise monitor, right? No, we don't have second. We have wise monitor. Okay, wise monitor. You do the monitor?
That's correct.
The first question.
Yeah.
Go here.
Yeah, monitor.
You should answer.
Come on.
Yeah, everyone trusts you. Oh, you know, this question is.
We can discuss.
If you want, you can discuss and then, but someone should come here.
Then we discuss.
Yeah, it's okay.
Okay.
Lisa.
You're on your own. You're on your own.
You're on your own. I studied economics. Okay. You're on your own, bro. Okay, how do you do it?
One more. Yeah. It's to say 6.02 kilo.
One more over n, right? Equals to?
The Avogadro's 1 more is equal to the Avogadro's thing, which is 6.02 times 10 to the power 23. Okay. Then, how many more? Just put the question mark there of x if you want to.
I've forgotten the formula.
Well, he is not, he is just ratios. Remember.
So,
Is equal to that 3 times 10 to the power 2, 3, 2 times 10 to the power 20. Isn't it?
Isn't it?
No.
No.
Guy, just do that.
So basically, you need to know the molar mass of atoms.
Wait, does that seem right to you?
So do you know what the molar mass of iron?
I am 56.
Yes, 56.
56. Yes, I know.
Yeah. Yeah, 56.
So I should know.
Wait, yeah. Oh, is that
You don't need that.
Yeah, is that-
So-
you don't need it.
We continue.
What should you know?
So how many moles? So now what the moles? Now you need the mass. You know the mass, right?
Yeah.
You know the mass, and also you know the molar mass. From this number, how to calculate the moles?
Number of moles is equal to the mass of molar mass.
Yeah.
So smart. This
This is the vice. Not this one.
What were we doing here?
It's big level.
This is the captain of the class. Like he just reminded me.
Yeah,
Mass.
mass is 8.2.
But even the top thing.
No, 232.
You can use it. I don't know, like the.
Okay.
You can also use it.
Yeah. And
This is mass.
yes,
This is mass.
no, definitely. Basically, you should not mass and green.
The,
No.
Yeah,
You can use it this way. Yeah, green.
Yeah, crazy.
Yes. Green, and then what do you
Yeah.
green? No.
Yeah.
Oh, molar
Molar mass doesn't have views.
mass. What's the unit of molar mass?
okay.
Put
What's
yeah,
the
but
number?
What
you
the-
put
what-
grams then comes.
See?
0.147.
What's the molar unit of molar mass? This here. See here. Green
Gram.
more.
Gram per mole. Okay. What's
0.147 moles.
No, you should write the unit here. What unit?
No.
No, more is
Grams
not.
per mole.
what's the yes
Gram per
gram
mole.
We showed you.
Yes.
I guess I already.
Okay. Yes, I give someone. Yeah.
So-
what number? What number?
Then cast out the graph. Yeah.
Yeah, 0.147.
7
Okay. Yes. Okay. Now you answer. You get the.
Now you place that number.
How many moles? So this number, right? Now, how many atoms are there in
Yeah. So you that
a?
the one.
Yeah.
The first one. Put that.
Well, yeah.
Put here. Yeah.
So-
Put that number.
Now you get the moles.
Yeah.
How to from the moles get the number of atoms?
Yeah.
So, yeah, if one more is equal to this one,
Yes.
how about 0?
Yes.
So,
Exactly.
So smart.
So smart.
Nisa,
What?
calculation.
So much I show.
James, what? 0.1?
I don't know what to do.
0.147.
2.1?
It's 8.85 times 10 to the power 22.
Okay.
Or we can just round to 8.85.
Don't go around.
That's all?
It's okay? No. Times 10 by
20. Okay, yes, yes, good.
Yeah,
Okay, thank you. Yeah,
Yeah.
see, we can see here. See? Yeah, so basically, here we know the mass, right? And using the mass divided by the molar mass, we can get the number of moles, right? And then after we get the number of moles, we can time the 1 mole has this number, right? Has the number of atom. We get this. Okay, good. Okay, now question 2. Oh, nobody want to come here to try?
He's representing the class. Class so correct.
Yeah, how many grams of water are there in pot 2 moles of water?
Let's write down there.
So basically, you need to know the
Write down the chemical formula of what.
the molecule of water.
Also got
H2O, right?
Yes.
And then find the mass is the molar mass of it.
This one is
Hydrogen
1,
is 1 times plus 1.
which is
I mean 2
2
plus
plus
16.
16,
Yeah.
18.
Yeah.
What's the unit? What's the unit?
Grams per mole.
The grams per mole.
Yes.
so it's 8.
So when you do calculations, you should always be careful is there are units, okay? Yeah.
Okay. So,
That formula.
grams per mole, right?
Huh?
What are we looking for?
16. Use that formula we used previously.
So now you know the
Numbers.
Yeah.
Mass of moles.
Yeah, then we have the number of moles, then the molar mass, we have then we get the
Mass over moles, which is 18.
equals to 1.
0.2.
Ways of making money.
Mhm.
You have a calculator.
Drop the 100 and get it back. It's life.
Put the units.
Too much. That's too much.
You see the book, yeah.
If I can't even take it.
I already did.
They said we need to get this.
Yes.
It's essential.
Okay. Good. So any question on this? Okay.
Please, have you understood?
Okay, thank you. So basically, so now we know the moles, okay? So we just using the number of mole is molecular mass, okay? And we get this. Yeah. That's oh wow.
First
Oh, you have 1 week, you know.
Yeah.
Just, yeah, give me your next Friday this time. You must, okay? The homework is 30%.
我作业老师，But I was right.
Okay, so that's all for today. Check.
Logic.